Hello everybody and welcome back. It's time to give you another update about the status of the bad6502 project, and well, I have new boards. JLC PCB finally came round to delivering them and getting them finished, and right now this design is, as far as I can tell, flawless. I also like the size and the placement of all the parts. I made some changes, I'll go into them later. And I also have the first batch of the big boards, and the big boards are capable of using a standard Raspberry Pi, not the Zero. This is a Pi 3 B+, and it works absolutely flawless. It has, of course, more connectors than the Zero, and it has them in a slightly more convenient form factor. You don't need any adapters. You have Ethernet, which I really love. Wi-Fi is cool, but for development you want something that's faster than that. Also, this board has the expansion slots, and it has breakouts for all of the signals from the processor, as well as two separate grounds to connect your scope to, which is very handy for finding bugs, believe me. This here was the old board. Yeah, it needed a few tweaks, but it also works very nice, I have to say. And I finally got some more Raspberry Pi 02s. I broke this one, and then I fixed it again. I just accidentally had the tiniest amount of solder between two GPIO pins, and of course it wouldn't work anymore. Well, it worked, but the 6502 wouldn't work when it was connected. Okay. So this here is one of the new boards that I've made, and no big changes. You can still really get to the reset and NMI switches. It does have the three breakouts for clock, RW, and IRQ. Those are for testing the most important pins that you need, because they usually make the biggest problems. You can also see that I have a connector for my ground now, which makes it a lot easier to hook up my scope. Talking about scope, I made some projections about the speed that I would be able to achieve with this board. And well, they were slightly off. A lot. In fact, the measurements that I made were entirely wrong, because it turned out that I had a broken probe on my scope. I think if we can manage the software and driving the clock and doing all of the memory reads and writes, we can go a lot faster. But right now we're limited of the capability of the CPU we're running on here. I've been able to get stable 2 MHz. I've also been able to get stable 3 MHz, but with a very simple client, a very simple board design that the Raspberry Pi was trying to simulate. Regarding the simulation, I have made some improvements to the code that I had, and I've worked a lot on getting other workloads onto the simulated part. The simulation always works the same. The 6502 is just the CPU. Everything behind it needs to be simulated. And I'm saying simulated and not emulated, because in emulation you can skip steps, you can make things simpler than they would be in hardware. for a simulation and for the CPU, everything has to look exactly right. In the back end, like when you're doing sound, for example, or you're reading a joystick input, that is a point where you can, again, do emulation. You do not have to be super exact there, but it pays off. So the newest thing that I've been able to get to work, and I have to prepare a little bit here, is something that I find absolutely amazing. And it's this, and it's going to be coming right here, right now. Ta-da! This is my first stable emulation of the Commander X16 in full-blown mode. Everything that is part of the emulator and everything that is part of the hardware is basically simulated here, and the 6502 is running the code. I can do a load of the directory. I'm still getting used to the keyboard. So let's get you a bit zoomed in here. Focus, please. And I have everything prepared like it was. So I have an emulated SD card right now, but I'm already working on the scripting for getting device change, like on a USB disk, for example, or a USB key, to have that represented inside of the emulator. So you could basically have a 3.5-inch disk that you can change, and it would be reflected inside of the simulation. And we can load X16 robots and run it, and it doesn't work. What? And we get Commander X16 the way it was meant to be. Only that my screen appears to be dying over here, but let's not look at that. Now we have Petsky Robots in all its glory, and it's running wonderfully. I'm really happy with this. We're still at 1.6 megahertz, but that seems to be enough to get a pretty decent experience. Also, NMI works and reset works, which means that I am not corrupting any ROM or any RAM part, which is really cool. So what's up next? Well, I am trying to get more Raspberry Pi hardware to cooperate with this. Right now, the Raspberry Pi 3B is working, the Raspberry Pi 02WH is working. I'm working on getting the Raspberry Pi 4 and the 400 here to work, but it doesn't look good right now. I don't know why it's not working, but it might be something small. Maybe it's something with the pinout that's changed. I'll just have to investigate. But I'm really happy that I got the large Raspberry Pis working with the development board, because that just opens a lot more doors. On the other hand, it seems like the Raspberry Pi 02W is available once again. I had no problems ordering more of them, and apart from the fact that I could only order one from one seller, they weren't outrageously expensive or anything. So maybe there's light at the end of the tunnel. The other thing that I want to do is I want to work on the emulation. I want to, well, the simulation and emulation, and I want to start working on my own operating system or hardware layout in simulation that I was always dreaming about, and maybe do some work there. But for now, I intend to do some more work on the X16 to get the performance better. There's still a lot of stuff to do. I was able to improve the standard read and write code for the simulation so that it's a lot faster than what it was before. I will do something similar, or I'll try to do it, for the read and write code to I/O space for the Vera hardware. I think there's a lot of performance that can be gained there. And then I'm going to look at streamlining the code that we have a little bit, just to make it run even faster, and maybe to improve the way I can multi-thread it. Right now I'm running with 3 threads, and it's very good. The load is distributed very nicely, but there's room for improvement, and that's what I'm going to try to find. So once again, thank you very much for watching, and bye bye.